Welcome back to our dashed lines project. Today we're going to animate the artwork that we created in part 1. So I'm going to go ahead and right click and select copy outer SVG, hop on over to this CodePen demo and just click here to Command V, paste in my SVG, and there it looks all lovely with that dark background. Now in order to animate it, we're going to use GSAP. So to be very clear, we do of course have GSAP loaded here. And I'm just going to create a GSAP 2 tween where the target is every path, and I'm going to animate the stroke dash offset to 0. Remember, that's what we got from the Lottie file, and I'm going to have it repeat 10 times. That's an interesting animation. Two things jump out at me. Running it again, the strokes are moving to the left, and it's sort of herky-jerky. Well, to get rid of that herky-jerkiness, I'm just going to add an ease of none, because what's happening is that a default power 1 ease out ease is being applied, so it's slowing down during every iteration. With ease none applied, we now get a very smooth animation to the left. I copied everything exactly as we saw in Lottie, and if we look into my source code here, you will see that the stroke dash offset is -96. While I'm here, I'm just going to change that over to a +96 and do the same thing in all of these, and I'll show you why that is wrong in just a moment. So now animating from +96 to 0 works exactly as we had expected. To finish up this animation, I would probably slow it down a bit by setting the duration to 1. And now we have something that matches what we saw in Lottie. And this looks wonderful. However, I really want to explore where those -96 values came from. So back here in Boxy SVG, I'm going to select this stroke right here, and you will see that in the properties panel, what do we have? We have the offset is set to 96. But if we look in the code, it's adding a -96. Let's go ahead and make this 0. And what that does is when it's 0, it gets rid of the stroke dash offset. But as I move to the right, the numbers here are getting positive, but keep an eye on what's happening to this -31. As I move to the right, those numbers go down and become negative, okay? I'm guessing that the interface was built so that if you move this number to the right, it would be sort of intuitive to see the dashes move to the right. However, behind the scenes, the dashes move to the right when the numbers go negative, okay? So here we're at 100, but in the code it's -100. So this is one case where what you see isn't exactly what you get. So the takeaway here is, let's go back to, 0 or whatever. As far as the code is concerned, in order to get the strokes to move to the right, we need to make sure that the stroke dash offset gets smaller. So what I did quickly in our code is if I changed this to +96, we're animating to a smaller value, which then moves those dashes to the right. And trust me, it took me a few minutes to figure this out for myself. I was quite stumped because I know I was using the correct values that I got from Lottie, but I was seeing something different when it came to animating with code. And when it comes to projects like this, again, the artwork is simplistic, the code is simplistic, but we get just a wonderful visual result. I'm going to set the repeat to 100 so that we have more time to explore. And I just really fell in love with what's happening here as these 3 strokes sort of diverge onto their different paths. It just looks elegant and beautiful. Now to wrap up, you may be wondering, where did this 96 pixel value come from? Whether it's positive or negative, why is it 96? Well, let's explore. Back in Boxy SVG, I'm just going to select my middle line here, and you're going to see that the dash length plus the gap that we have is going to be 48. And that's really the number that we are interested in. Now it just so happens that 96 is what you get when you multiply 48 times 2. So this offset, as long as it is an increment of 48, is going to work for us. But let me explain why that's important. I'm going to take this straight line, move it over here, and then let's zoom in quite a bit on it, make it big, and I'm just going to option drag a copy down so that it's virtually in the same exact horizontal alignment. When you're making seamless repeating animations, what you need to do is make sure that the start and end states match. So what we're doing in our animation is we're moving these dashes to the right, okay? So what I'm going to do is show you how I can animate the offset of this path to match the one above it, sort of as a guide. I'm going to start out by resetting the offset to 0. And as we've seen before, changing this value is going to make those dashes move. And when I get to a value of 48, which is right about here, you'll see that the dashes are lined up with the original. If I change this number here to something like 60, well, they're not going to line up. But if I go to 96, which is the next increment of 48, it lines up perfectly. So again, the dash length plus the gap is the number we're most interested in. So with that said, in my code here, I can animate to a stroke dash offset of 48, and it will be exactly the same, except it will be much slower, okay? It'll be half the speed because we're going half the distance in the same amount of time. By going a full 96, if I bring this down to 0, that of course is going to be a faster animation. Going from 96 to 0 in 1 second is going to be a faster speed. So hopefully this clears up how this effect was made, and I hope it inspires you to build something similar on your own. I strongly urge you, crack open a vector program, whether it's Boxy or Illustrator or Inkscape, and try to make something like this. Go into the Lottie Lab gallery, look at the other examples, and maybe you want to add some extra flair like they have here in this little centerpiece. All of these little things that you practice are going to help you immensely. So dive on in, drop a comment below. I'd love to see your work, and let me know how you're enjoying GSAP Summer Camp. See you in the next video.